Hello everyone.
Hello.
So welcome to our second workshop, which is for data cleaning using Tidyverse package in R. So today I'll welcome you all on behalf of VU DASA for our second workshop that is based on data wrangling using Tidyverse. So agenda for today, first we'll have a little bit of introduction. What is data wrangling? Then what is Tidyverse that we are going to use, and more coding practice using Starwars dataset. First of all, I want to know uh, how many of us do you have any access to R? Are we all sorted with access to R Studio and account on R Studio? Is there any issues in that? If so, you can raise your hand and ask freely about that. I guess all have the access to R. Does anyone wants any help in setting up an R Studio account?
Hey, this is Ajay. This is my first session with you actually.
Okay.
Actually installed R and R Studio, but it didn't ask me for any R account or something like that.
It's perfect. If you are using the desktop version of
Yeah.
R Studio, it's completely fine. If you want to use R Studio on cloud, then it
Oh, okay.
asks for your email account or some
Okay,
email
perfect.
address. So if you are working on desktop version, it's completely fine.
That's fine. Thank you.
So let's move further. Now let me introduce what is data wrangling. My system is getting slow today. So data wrangling is a process that we use to turn messy data into useful statistics. We collect data that, for example, in organization, a sales team collects data about sales of a particular product. They survey around various regions. In some variables, they don't have value. Some people didn't respond. So that data term converts into a very messy data or an incomplete data to work on that may predict wrong results to our organization and may uh, leads to loss. So we do data wrangling and cleaning to make our data understandable, to organize our data so that we can predict more useful results, to analyze the data in a great manner so that we are on a profitable path and visualize the result also. We can use graphs, bar charts, 3D mapping so that we can plot our result on the maps and give a clear view of the data or the analyze. For example, a sales team of school books creates a survey in Melbourne that this particular book is having so many customers. So we analyze that using different methods in R and can predict the result and visualize the result to our audience, to a specifically to a non-technical audience who don't understand code. We just analyze the data and gives a visual representation of our results. Fine. Now, to do the data wrangling in R, we generally use main library, that is Tidyverse. Tidyverse is a collection of R packages that provides numerous solutions to data wrangling. As we can see in the image on the left hand side, Tidyverse is a big library, sorry, which has many libraries incorporated inside it. For example, ggplot, dplyr, readrtable, stringr, forcats, tidyr, and pur. The main library we used for data visualization to plot graphs is ggplot. Tidyverse library includes various modules through which we can create graph, read files, and clean data. We'll go through all the libraries in our further workshops. For today, we'll stick to data wrangling using Tidyverse and major libraries like ggplot, dplyr. Now let's do some coding using Starwars dataset. Now over to you, Amanda.
Thanks, Swati. So, all right, so you can see my R Studio here. Okay, now, Siddharth, you asked a question in relation to the today's workshop recording. Now, at DASA.VicUni, we always look at the process of learn while doing. So we're in the process of editing the workshop videos. So when they're finalised, we'll be able to load them onto our YouTube channel and send a link out to everyone for the workshop. So please bear with us while we get those workshops organised and set up to be able for publication. So, but they will be available for sure. And also we will be providing a link to a GitHub repository with all of the script and the coding. But the workshops themselves are actually designed for us to work along together and have that real interactive component to them. So, so let's just begin. So you'll see that I've got my RStudio file here. This is the same project that we started with last week. So all of our libraries should actually be installed. So we shouldn't have to install our packages, but let's just see what happens. So the first thing that we do need to do is load our libraries. So once the packages have been installed, we need to, you may recall, we need to actually install, load our libraries. Okay, so we're working with the Tidyverse library, and that actually works. So there's no error codes in my console. So that's great. And it's running through the process. So we're using the Tidyverse and just one other package called knitr. So knitr is one of the packages that presents things as a table, and it's a really nice, pretty sort of table formatting process. Now, I've actually, last week, we worked on RMD files. Today, we're just going to focus on the actual data and the Starwars data set that's inbuilt in R. So we're not going to be focusing on RMD. All I'm doing is running an R script file. Okay, so I better save this one. And we'll just call it Starwars. And Starwars script, that'll do. Okay. All right, so let's have a look at our Starwars data set. Now, as you can see in here.
Sorry, Amanda. Last time I wasn't in this workshop, so I don't have this data set.
Ah, you do have the data set. It's actually inbuilt into the software. What you probably haven't done is installed your packages. So install.packages, Tidyverse. And
yeah, yes, I have that one, and
you have that one?
I already installed Tidyverse and also the K-near one.
Okay, all right, excellent. Excellent. I'm not going to run that because it'll take a little while. Now, I'm just commenting that out so it doesn't run again. Now, what, Javier, just have a look at View Starwars and let me know if you get a data set at the back end here. on a different file tab. Because this is one of the data sets within ART, and there's quite a number of data sets that are available.
Yeah, got it. It's there.
You
Yeah.
got it?
Thank you.
Excellent.
Yeah, thank you.
No worries. Okay, so now what we've got, we can see Star Wars. We can see it here, but our environment is empty. So we're going to assign it to a variable. Oh, we're going to give it a name. Data and Star Wars. So now we can see here that we've got our data set of 87 observations, which are the rows, and 14 variables, which are the columns. Now, if we click on the name data, we can view the data set, and we can see that it is exactly the same as the Star Wars one. Okay, let's just save that, because we always need to keep saving our files, because we don't want to lose any of our analysis. Now, one of the things about data wrangling is that we actually need to really understand what our data set is. Having an understanding of 87 observations and 14 variables gives us a good overview of the size of the data set, but what is it made up of? So one of the things that we can do is just use head, which is a function to be able to just have a look at the top of the data. And we're going to say we want to have a look at the top 10 rows. And over in our console, it actually gives us a bit of an idea, and it's not a very good display in my console, that we've got 10 rows, we've got the name, we've got height, mass. Name is a character, height is an integer, mass is a double, which is an integer with decimal places. And we've got various other hair color, skin color. Now, sex is also a character, gender is a character, but then we have these ones here, films, vehicles, and starships, which are lists. Now, we're going to talk about those lists a little bit later in the workshop. Now, that's the top 10 lines, and there's also tail. And we can look at the bottom 15 lines. And so, you know, it's just giving us a bit of an understanding about what our data set is. And it's very useful if the data set is big. And you know, when you've got 64,000 observations and you have 30 and 40 variables, it's a useful function to be able to look at, you know, what is the top and bottom, especially after you use arrange functions and things. We are going to look at some functions, very basic functions that give us an understanding of our data set. We're going to look at filter, select, slice, and arrange. So filter is about actually selecting and filtering or manipulating the data set via the observations. So we can actually filter for each of the rows. Select is about looking at the variables, so working with the columns, and we'll work on those a little bit. Now, what we're going to do, because we have our data set here and we've got 14 columns, and these last 3 columns are lists, I'm actually going to ignore those for the moment. I don't want to work with them at the moment. So I'm going to assign the data. I'm going to overwrite this data frame. And I'm going to select our Star Wars dataset and just checking to make sure I typed that correctly. And I'm going to select columns 1 to 11. So now what we have is when I look at the data here, we've only got 11 variables. So those last lot of last columns with the lists are missing from this data set now. Okay, so let's do a little bit of wrangling. Let's understand what happens here. So filter. Now we've got to enter in our data frame. And I'm going to say filter. I'm going to look at all of the what species. No, I'm going to find out what are the characters that have actually come from homeworld tattooing. Now, so homeworld. So I want to filter the data set where homeworld equals tattooing. And we have to get the spelling correctly. Now, you'll notice here, so we're saying we want to filter this data set with this variable is equal to tattooing. So we've got the capital letters, that's great, and homeworld is with no capital. Nothing's happened down here. Now, what I've got is a tibble with 10 by 11. So it looks like we have 10 characters that have come from tattooing. Now,
sorry, Amanda, can you repeat the last step, please? I want to really understand what are you doing there.
Sure. So the filter is a function in the Tidyverse. So we are filtering the data frame data, which has 11 columns. And we're filtering on this variable for all of the observations that equal to tattooing. So what we're trying to understand is how many characters come from this homeworld tattooing. Now, when we enter that and when we run that line of code, it gets a little bit difficult to see this table of, we've got 10 characters with 11 columns, 11 variables. So what I'm going to do is assign that to a data set called tattooing. Now, a lot of people, and we'll talk about this in a moment, about a lot of people actually use the piping functions to be able to string together a number of different functions and activities and all that. But when you're learning and when you're actually trying to first understand what's going on and making sure that your code is actually giving you what you want, I'd like to actually assign almost every step to a particular data set so I can see what's going on. And then we can go back a little bit later and actually clean up the code. But when we're first sort of, analyzing and exploring the data, then, I like to understand, and I end up having lots and lots of different assignments here. So if I look at tattooing here, you'll see that we've got 10 entries, and the homeworld is all tattooing. And so we've got all of our 11 columns. And so we're just taking a small subset out of that data set. So something that we can work with. So the select function works with the variables, which are the columns. The filter function works with the rows, the observations. Okay.
So can you repeat what the select function do? I totally understood what the filter function do, but a little confused about the select function.
Okay, so the data frame is actually made up of rows, which we refer to as observations, and columns, which are the variables.
Yes.
So you understand how the filter works on the rows?
Yes, yes, totally.
Yes, well, select is exactly the same, but it works on the variables, on the columns. So,
Okay.
what we can do here, just to give you an example, we can just go, I'm just going to say data 2, and you don't have to type this in. Select Starwars, and I'm going to say name and height. Now, is that? I've got to make sure I get the correct spelling. So name and height. Now, let's see what happens here. Now, so what we've got here is data 2. So I'm selecting, so from the Starwars data set, I want you to select the columns or the variables called name and height and assign it to data 2. So when I look at data 2, I have the 2 columns, name and height. And I have the all of the observations, the 87 observations.
Okay, thank you. Totally understood. Thank you.
Okay, great. Is there any other questions? All right, we'll move on. Okay, now, so we're just working with filter for the moment, and we're going to stick with our the filter functions. And let's look at filter data, and we can combine the functions. So let's look at home world. Wish I could type. Anyone know of any really good typing practice? Okay, so now, and if we actually put in the correct variable name, now what we have here is we are filtering the data set for 2 variables. So the home world equals Tatooine and sex equals male. Now the filter function works exactly based on the set series. So we can use functions called equals, less than, greater than, and, or, and not, to be able to gather the data from our data set. Now, again, this is something we've assigned this information here, but it's only in the memory from R. There's nothing. Our global environment and our data frames haven't changed. Okay, so let's call this Tatooine 2, because that's the way we roll. We're very I can't think of the word. We're very creative. We're very creative. So if we go to Tatooine 2, we'll see that we now only have the males from Tatui. And so we're actually splitting down and filtering down our main data set. So our number of observations are being reduced. All right. Okay, now using the pipe function. The pipe function is a way in which the Tidyverse allows us to nest and coordinate different sets and different functions together. So what we're going to do is we're going to use our data frame, and we're going to pipe the data. Now, are you familiar with the piping function? It's the syntax is the percentage, the greater than sign, and the percentage sign. So that is a symbol that that we need to use. And so we have data, pipe. All right, so I'm going, just to make sure that you guys get it, I'm going to just type the symbol into the chat. So just so that you know exactly what it is, because if you mess up the syntax, well then your whole line of code won't work. So we're going to pipe. Now you can enter down to different lines. We're going to filter sex equals to female. And then we're going to pipe another one and arrange by homeworld. Now, let's just talk about this whole process a little bit here, because we're looking at our data, our original data set with 11 variables. We are filtering on all of the rows so that all of the rows that where the sex is equal to female, and we also want the output to be arranged via homeworld. So if we actually look at this, okay, all right, so the piping means do this or use this, and then do this, and then do this. So you're actually nesting your groups, you're nesting your functions. We can actually also do it like this as well, but it just means you have less lines of code in your file, but it can be quite difficult to read. So I'm going to say this, call this test one.
So we are actually arranging and filtering this female and home world from the main Starwars data?
No, from the first data. So we, the Starwars data, we assigned to here, but then what we did is we only selected the first 11 columns.
Okay.
So remember, we got rid of those columns that had the list, because we're ignoring them because they're a little bit difficult for us to work with at the moment.
Perfect.
So, but before the end of the night, you'll know how to work with lists. Yeah, so we're using this data frame. So working with this one, we're filtering for sex equals to female and arranging them by homeworld. Now I'm going to run test one. And let's have a look at test one. So we have our names of all of our characters. They're all female. And homeworld has been arranged alphabetically. Now, what I'm going to do, just so that we can understand this piping function, we're going to call it test 2. We're going to say data. No, we're going to go filter, data. You know what? I should just copy and paste this. I really should. Right, so I'm going to run that code. So if I look at test 2, we have 16 entries. So there's 16 females, which is exactly the same as test 1. Now we have all of the females listed here, and the homeworld is actually, this data set is actually hasn't been arranged by homeworld. It's just in accordance with the line entry corresponding in the same order as the original data set. So we can arrange by homeworld. So now what we can do is we can say test 2 no, let's do it this way, just to show you. Arrange test 2 by homeworld. Let's see if this works. So now when I look at test 2, is it organized? No.
Amanda, could I ask, what's the use case for piping over doing these methods in separate order?
Well, this is exactly what I'm trying to show you. So now what we have to do by actually, so we've done test 1 and we've nested them to say, use this data and then do this function and then do this function. Now I'm going to get to exactly the same thing, but I've already got, okay, use the data, filter it on this, assign it to that, and then arrange that based on this and assign it again. Or we can assign it to test 3. So what it is actually a really an easy way to be able to coordinate your code about what you're doing and following it. So if I now look at test 3, I have all of the names. They're all female and they're all ordered by homeworld.
So it seems piping's just a more elegant way to do it.
Elegant is a really nice way of putting it, yes. And it also, it allows you to follow the process because for here, I'd have to go, okay, now that's test 2, now test 3, now I've got to go back to test 2. So, let's get rid of this bit and just work with test 1.
Thank you.
Okay, now also our environment here is getting a little bit messy. So let's remove test 2. Right, so we can remove our test 2 from here and we can just delete it from there. We don't need test 2 and we don't need test 3 either. Okay, so we've just had that process of showing you guys how to work with that. Now remember that the variable names do not need to be in quotation marks, but the observations need to be in quotation marks. Okay.
Then also homeworld is an observation, right?
No, homeworld is actually because it's up here in the
Okay, okay.
it's the name of the
Got it.
variable. Yeah.
Yeah.
Okay. So I'm just sort of wondering, right, we've got to, let's skip over a couple of those things there. And now let's go back to no, we'll do this. Okay, so let's look at our data, and then we're going to pipe again, and we're going to use a function called slice max. Now, slice max actually gives us the maximum values, and so it's a really good thing when we're using a numerical variable. So if we look at our height, and we look at the top 10, so n equals 10, sorry, and we run that one. So what we're going to do here is see that the height of the tallest characters in our data set are these ones. And isn't it interesting? Chewbacca's actually not the tallest character. I thought he would have been, but there's quite a difference between him and this guy here. Okay, now corresponding to slice max, we also have slice min. So I'm just going to copy and paste this and change this to min, because you guys really don't need me to see me typing blunders all over the place. Now, this is our, you'll see here, this is a tibble that's 10 observations by 11 variables. So this is our top 10 tallest characters. Now we're going to look at our bottom 20, our shortest characters. So then Yoda is actually the shortest one. So there's no surprise there. So Yoda's the shortest one at 66 centimeters, whatever variables they've chosen for that. And it looks like Padme is one of the shorter ones as well. Okay, that's probably about my Star Wars knowledge of characters, because I actually preferred all of the original 3. Okay. Now, let's actually work a little bit more with the piping function. And before we continue with the piping, is anyone need any further clarification on what we're doing and how we're looking and examining our data set?
Amanda, can I ask how you sort in descending order?
Yes. Okay, so what we can do when we go arrange, now, so now if I type in here arrange,
I was actually just thinking on the height, actually, just tallest to shortest. And
yes, yeah, for sure. So now I'm just, there's a couple of things here. So actually, can I just move on to the next line of code and we'll add it into the next line?
sure thing.
Yeah, okay. Because what I'm going to do is I'm going to look at our droids. And I've got an arrange function within the droids, and so we can actually work on that one there. So So we're going to look at our data and pipe. We're going to filter for species is equal to droid. Now I'm going to select a few columns: name, height, mass, and home world. Oh, look, I can just click on that one there. It saves me typing. And then I'm going to filter it again. Oh, sorry, pipe it again and arrange by height. Now, I'm going to assign this one to a data set called droid. So you understand, everyone's got the fact that this assignment code actually means that we're putting the analysis into its own table and data set. Now we can just click on the one of the lines there, Control Enter, and we can run the program, or run the code. Okay, so we've got 6 droids here. And they're in natural order there anyway by height. But let's look at arrange. I think it's arrange descending. Oh, geez. Do you know, don't you hate it when you've got a blank? Swati, if you can remember the code, just feel free to jump in.
Yes, it's the same. Arrange descending and then height. Yeah.
Yeah, that's it. All right, cool.
Yeah.
Thank you. Okay, so if we look at droid, so now we've got the height in descending order. Okay, does that answer your question? Sorry about that.
It does, thank you.
All right, so what we'll do is we'll actually take out the descending height just so we can show the actual order. And if we look at droid again, the height is now ascending. Okay, cool. Now, what I want to do is actually have a look at this information here about the height and the mass, but probably not with the droids, because there's only 8. There's only 6 droids, and they're not really that interesting, except for C3PO. So let's go back to our original data. And let's look at our function called mutate. This is something that we haven't discussed before, but when you're doing the data analysis, you need to know how to add columns and actually perform functions. So mutate is actually going to be one of your friends. So we're going to go back to our data set. We're going to pipe, and we are going to mutate. So height, in meters, or height m, equals height divided by 100. Now let's have a look at our data set. So we have a height here. We don't know what variables, what units of measurement. But what we're going to do is, so we've got, ranges from 66 up to 264. So when we're mutating, we're actually going to add a column. So we're going to say the new column, height M, is equal to the height column divided by 100. Now let's run that. Now you'll see that, well, we've still only got 11 variables because we're actually running this data set and haven't assigned it to anything. But over here, you'll see that we've got the table of 87 observations with 12 columns. So it's added the column in its memory, but hasn't actually done anything. So let's go data. So we can actually assign this function now and overwrite the data. So let's run that. Now we now have data with our 12 variables. So if we look at this spreadsheet, we've got our height M now. So we've got our height, presumably in centimeters. Well, we're going to say it's in centimeters, and now we've got it divided height in meters. So mutate is actually a really, really valuable function to use. Okay, so now we've got our additional column. Then we've assigned it to data. Let's see what else we're going to do. Okay, let's now pipe this. Let's call it to, let's override data to, we don't need that anymore. And let's select height in meters. So we can choose this one. Height. And then everything. I've got a feeling that we can, I know what's going to happen here, but let's just see. Now let's look at data 2. So what it's done, what this code has done is actually selected height in meters. It's selected height and it's repositioned the columns within the data frame. So we are telling, by using this code, saying select this code, this first column, the second column, and then all of the other columns after that. Okay. Now, oh geez, we've still got, I'm getting the message to wrap up that we're running out of time. But we haven't discussed lists yet, and there's still, and there's a few more things that we can do with the BMI. But I'm just wondering whether or not, what do you guys want to do? Do you want to continue on and work with the lists, or are you happy to just come back next week and work on the list then? Feel free to call.
Happy to work right now.
Happy to continue working?
Yes.
All right, Swati, is that okay?
Yes, absolutely.
Okay, all right. I'm going to skip over all of the other stuff I prepared. And I actually am going to show you, let's work with the list, because I think when you're analyzing data, understanding the framework and working with lists is actually really important. So now what I want to do is, and I'm going to sort of rush through this a little bit more and just copy and paste because the code is quite big. But feel free to call out if you want it into the chat and understand the process. So now we're going to go back to the Star Wars data set. We're going to go back to the original one with all of the 11, 12, 14 columns. Now I'm going to filter on species and films. Now, and then I'm going to call this Star Wars droid. Jeepers. See, this is what happens when you start rushing through. What I'm going to do is I'm going to filter the Star Wars data set, and I'm actually going to assign it to droid. So we are going to filter on species and the films The Empire Strikes Back, because I want to know which droids actually were in The Empire Strikes Back. So let's go to droid. We've got one droid here, IG-88, that is in The Empire Strikes Back. That's not right. Because when we go back to our other information here, what were we doing? When we looked at this one, and if we change this data to Star Wars, and so now what we're doing is we're using the Star Wars data set, filtering on species equals droid, and we're selecting these columns, and let's select films. And we don't need to arrange by height. So let's just run this. If we look at droid 1, so we now have, we see that C-3PO and R2-D2 are actually in The Empire Strikes Back. But our code down here says that only one droid is in The Empire Strikes Back. So if we didn't actually understand that this column here, films, was a list, and we don't work with the list in the way that it is, then we would actually be analysing wrong information, and it could be very embarrassing, and it could be very costly. So we need to actually learn how to manage and work with these lists. So the
Amanda, how will I know if that column is a list?
That's a really good question. That is a really good question. Now, there's a couple of things that we can do here. Now, I'll go back here. If I look at Star Wars, there is a function called structure. So str. And so if we look at the structure of the Star Wars, it actually tells us that, we have to go right up to the top, it tells us that the name variable is a character, the height variable is an integer, the mass numerical, and then we have characters, numericals. But here we have film is equal to a list of 87.
So how do you set, in your data set, how do you actually tell RStudio that that is a list? Is this what you're doing in here in the structure? How do you define that?
I don't know how it actually tells it it's a list, but when you actually work with data, when you're collecting data from different sources like JSON or Python or other data frames within a business, it actually allows us to record data like lists. And so I actually see the list like a three-dimensional spreadsheet. So you have your X and Y variables, but then the list is like the Z axis, to say that you've actually got a lot of different variables in that one space. And we're not used to working with lists within a two-dimensional space. But it is something that the way in which it captures, that's the extent of my knowledge about lists, but it's more about how the data is captured from the source feeding into the file that we're working with R. So yeah, look, we can probably investigate that a little bit more in the future to be able to answer those questions, but it's probably the actual programmers that will define that process. Okay, so now we understand the importance of actually being familiar with our spreadsheet and our data, because we want to get this right. Now, working with the list in Starwars, let's get rid of some of these. This particular format of lists is a term called, it's a nested data. Now, this does not follow the process of the Tidyverse. Tidyverse wants tidy data, where there is a single observation, a single value for each row and each column. So what we're going to do is actually use some functions to be able to unnest this data, so then we can actually work with it correctly. I'm just going to copy and paste this because I did actually have to prepare this one earlier. We're going to use a function called unnest wider. Now, if you're familiar with terms like pivot longer and pivot wider, then you'll understand the concept of the making the data expand out. So what I wanted to do here, by using unnest wider, I wanted to actually say, okay, this is a film. This character is in this film. And so then I want to spread out and make more columns so that I've got film 1, film 2, film 3, film 4, so that we can work out which characters are actually in which film. So that's why I'm going wider. I'm actually putting in more columns. So when I run this code, so we're using that terminology, unnest wider. So that's the function. And we're using Starwars as the data frame, and we're unnesting films is the variable. And we're assigning it to a new data set called Starwars films. So now let's look at Starwars films. So we've still got our 87 entries. Now we've got 20 total columns. So what we have now is we have column number 1 for them, column number 2, So this is where the additional films have actually been split up. And so now we don't have a nested list of films. We can also do the same for vehicles and starships, but I'm ignoring them this time around. I'm only interested in films. And you'll see here that we've got some NA variables now. We have, so this character was only in one film. They didn't appear in any of the others. But it gives us something to work with. Okay, now, yep, you have a question?
I was just going to ask, if you're given a data frame where the observation or that list is not as clean and neat as what we have in Star Wars, where every title has the talking marks, can you still do it with the commas? So let's say there's no commas or no talking marks, and within the list you want to break it up as you have for the various different movies into different columns. Can you still do what you did then, or would you have to go in to the particular list and add commas?
I actually think that there's particular arrangement where you can specify a separator. So if you may see, like this one here, Imperial Speeder Bike is in quotation marks, but this one is not. Now this is under the vehicles, but I can see what you're saying about the different formats. And this one is character 0. So this doesn't have quotation marks, but this one does. And so you can actually specify the separator. So you could specify a separator as being a comma or a colon, or you could specify it as being spaces or tabs, depending on the nature of your data.
Thank you.
But again, it is about being familiar with the format and how it actually is presented. Okay, all right, so we've got that. We've got our Star Wars films. We've got our column variables, which are 1, 2, 3, which the names are really not very useful at all. So I'm going to rename the column. So, and I'm just going to copy and paste this in here, and I'll copy and paste it into the chat as well. So what I'm going to do is use the rename function to rename the column or the variable that is named as ... 1 as film 1. It's quite a, I think it's quite a backwards way of saying the syntax, but they're saying replace film 1, use this one instead of that one. So, you know, it's a bit hard to get your head around, but if we look here, we can see that film 1 is actually now being the title of this first film. So it just gives us a little bit more control over our variables. And because we need to clarify this, and I'll add it into here, we can actually rename all of the columns, all of the other columns. So rename 3, 4, 5, 6, and 7 with film 3, 4, 5, 6, and 7. And let's run that one and look at Star Wars films. Okay, so now we've got film 1, 2, 3, 4, 5, 6, and 7. So now you're getting an understanding of what a tidy data actually looks like. The tidiness isn't concerned with the NA variables. the tidiness is about having a unique value for each observation and each row. Now, we've just got 2 more lines of code, and I'm just going to copy and paste it here into the chat and here, just to save time, and let's discuss it.
Sorry, Amanda, is there a quicker way to do that? Like, what if you have 20 different columns? Are you gonna go film 2, film 3, 4? Like, that would be a lot, right?
There is a way in which, oh, Meryl, that's cool. There is a way in which you, oh, geez. I didn't know you could do that. I'm learning things too. There is a way in which you can actually name things and select columns and all of that and rename. But sometimes it's about understanding at what level do we want to put our code. Now, when I'm talking about this film 1 colon to film 7, that is like select film, the column film 1 all the way through to column film 7. So there is a way in which we can rename them, but you know, it's I just didn't look at that for this workshop. Okay, so film's final. What I'm doing here, I love your artwork, Meryl. I really do. Okay, so we're looking at our Star Wars films data set. We're selecting the name, the species, the homeworld, and columns film 1 to film 7. Now, I'm just going to run this code just by itself. So we're looking at film's final, and now we have 10 variables. We have our name, species, homeworld, and our films. But in order to answer how many, our original question about how many films do Star Wars filter species droid, the droids, filtering about the droids and the Empire Strikes Back, we now need to be able to analyze this data. So how do we actually filter and collate the information in here? So what we're going to do is actually use the pivot longer function. And this is another really valuable function, very similar to creating pivot tables in Excel, if that's what you're familiar with. So we are going to now take all of these films and all of these variables, and we're going to make them longer. Now, so then we will end up with one single column and Luke so we will have Luke Skywalker repeated down the side, and we will have each film listed down in the one column. So let's run this. So we're going to take the columns, we're going to pivot longer, the columns from film 1 to film 7. We're going to assign the names to the film and the values to the title. Let's just run it. Okay, let's look at film's final. Okay, here we go. So we now have Luke Skywalker. He's a human from Tatooine. He's appeared in film The Empire Strikes Back, Revenge of the Sith, Return of the Jedi. And the film, this was the film number 1, 2, 3, 4, 5, 6, 7. We don't need this column anymore because we have the titles of the films that all of these droids are actually entered in, have appeared in. So now we can actually do some data analysis on this. And so let's go back to our original question. Film's final values to title. Okay. All right. So let's just put this one in here as well. Just checking to make sure that you guys have got all the code here. So we are going to filter the species for droid and title equals Empire Strikes Back. Now, remember, it only had one record of it when we first did the analysis. And so when we look at droid films, we now know that there's 3 droids that appeared in The Empire Strikes Back. So we are now confident because the list has been unnested and the data is in a tidy format, we are now confident that that information is correct. Now, I know, I feel like I've rushed through this a little bit. So if there's any questions that that you have, please let me know.
Yes, it's very good explanation. Everyone is good.
Everyone's in shock. Now,
Yeah, no, they are enjoying this.
okay. Excellent. Thanks for your comments, guys. I really value your involvement and the engagement with all the participants, because you know, with coding and R and anything that's new, you really need to actually get in and do it. So and practice and practice and practice. All right. So if there's no questions, I will wrap it up because we have gone over time, and I'm just sort of wondering, you know, probably an hour and a half is probably a better time frame, because once we get through an hour, we just don't seem to get too much done. But I will be putting video casts onto a YouTube channel. Once that's all edited, I'll also be putting the script into a GitHub account and a GitHub repository, so that you'll have access to all of the script that you can look back over, you know, in the future. Also, if you have any questions or you'd like to have a discussion or anything about some functions or some packages that you would like to explore, please send us an email at DASA.VicUni@gmail.com, and we can incorporate that into future workshops. Now, next week, we will be looking over the plastics data set and doing a little bit more statistical analysis charts and working through to ggplot and the actual data visualizations. So we've got a really, really interesting workshop scheduled for you next week. So now, if there's no more questions, feel free to sign out, and thank you so much for your time. Oh, actually, AJ, I will put this in here now.
Also, when you actually upload the videos to the YouTube, how will we come to know which channel are we looking at?
We will send you the links to our DASA YouTube channel, and so
Okay.
then each of the workshops will be titled so that you can to run them through.
So
But-
to register for the next week's session, are we supposed to go to the same website which we did for this week?
For Eventbrite, yes. So each of these workshops are actually run and organised through Eventbrite. so
Okay.
that we can get the registrations and the Zoom links out to everyone.
Mhm.
But we will be able to email you with the links to the YouTube site for where you can access the screencast, and you can also you'll be able to get a link to our GitHub repository.
Perfect.
And
also,
moreover,
in
I
case,
want to, sorry.
yeah, go ahead.
I want to add, you will get the registration link for the next workshop by tomorrow on your email IDs. So
Okay.
you don't have, you can access
Perfect.
from there.
Yeah, excellent. And thanks, Swati, you put the Gmail or the email into the chat as well for any communication that you would like. Okay, excellent. Thank you all very much. I appreciate your attendance and your involvement. It's really exciting and to have everyone being so engaged. So I really appreciate it.
I have a small doubt, if you don't mind.
Yeah, sure.
Actually, it's not related to this workshop, though. I have some issues in connecting my RStudio with GitHub. You know, it's really taking me hard time to understand how do I connect the GitHub with RStudio, because when I see at your console, there is a terminal part in your RStudio, but there's no terminal in my RStudio.
Yes, yes. What I've actually had to do is when you create a new project, save it. Okay. When you create, you go to version control.
Yeah.
And then from the version control, once you've got Git and everything all set up, you need to go into Git to.
It doesn't show me, like when I click on the Git over here, it says that Git is not installed, but Git is installed actually.
Okay, so there's probably a password connection. Have you verified your GitHub?
Yeah, everything is done.
Okay.
But when I use a new project from the right-hand side to create a project, it will work for me to get into the repositories. But when I use a new project from the left-hand side, it doesn't allow me to get into GitHub.
I don't know what you mean by right-hand side or left-hand side.
Okay, so on the right-hand side, can you see DASA workshops?
Yes.
Here, when you click it and click on a new project, new project.
Oh, okay.
From here, it allows me to interlink it with GitHub. But when I create a new project using the file, it doesn't allow me to connect it with GitHub.
Okay. Look, I really don't know. I don't know enough about R to be able to advise you on that one. So because this one just goes straight to my version control. So
got it.
Yeah. So yeah. Sorry.
Will you be able to help me with the terminal part?
No, sorry, I know nothing about the terminal.
No worries.
Yeah, so you.
Yeah, this one. I can't see terminal in my RStudio.
Oh, you can't see it. Okay.
Yeah.
So have you tried view?
Okay, view.
And you can look at, like, this is a console pane. So if you go to panes and console, then there may be ways in which you can actually
view it.
Yeah.
Okay.
Yeah, so there's a couple of different things here. Another option would be is to put in a search through Stack Overflow. That may help you out with that one.
Perfect. We'll try it.
Yeah. So sorry, I don't know enough about it to be able to just sort of discuss and tell you exactly how to fix something, because
yeah, that's fine. That's fine.
Yeah. So but you know, like if we're working together, we could certainly sort of try a few things and all of that sort of stuff. But it's sort of outside of my sphere
Yeah,
of knowledge.
Perfect. No worries. Thank you so much.
No worries, AJ, and
Have a good day.
thanks, you too. Okay, so thank you all, everyone. I'll stop sharing now. And I wish you all a good night, and I hope to see you next week.
Good night.
Thanks, Swati. You're a champion.
Thank you, Amanda. You explained so well.
Thanks,
Thank
Amanda.
you. Thanks, guys. Have a good night.
Too.